Hello, thank you for joining me today. My name is Nicole Salomons, and I'm a sixth-year PhD student in the Social Robotics Lab at Yale University. The title of the talk today is, We Make a Great Team. Adults with low prior domain knowledge learn more from a peer robot than a tutor robot. There have been many prior studies looking at robot tutoring. However, in 86% of prior studies, the robot has taken on the role of either a teacher or a tutor. Furthermore, most of the work in robotic tutoring has really been focused on tutoring children. However, should we restart rethinking the roles that a robot takes when instead of interacting with children, it interacts with adults? We took inspiration from education studies and psychology, where we saw that participants not only learn from their teacher, but also learn from colleagues. And often they learn even more from their peers than they do from their teacher. Therefore, the main question of our research study is, when tutoring adults, should a robot take on the role of a peer or a tutor? For the purpose of this experiment, we devised an electronic circuit building task. Now, there are several reasons why we chose this task. The first is that most adults do not have prior circuit building experience, allowing them to learn several new skills during the interaction. The second is that because there are many skills necessary to complete this circuit, there are many opportunities for the robot to intervene and provide personalized help. Another characteristic of this task is that a computer vision system is necessary to observe what the user is doing on the circuit board, and therefore observations are often very noisy. Therefore, we created our own user skill modeling algorithm, which we call CBKT, to model a user's skills during the interaction. To test how the different types of robots, the peer robot and the tutor robot, are perceived, we created two conditions. In the first condition, which we call the peer robot condition, the robot was introduced by the experimenter as being either a colleague or collaborator. And during the interaction, it used we or us pronouns. In the tutor condition, the robot was introduced by the experimenter as being a teacher. And during interaction, it used you pronouns. Other than this, we maintained everything in the experiment constant to really study the different perceptions people have depending on the robot role and whether they learn more from one robot versus the other. Here are some examples of robot utterances. So for example, in the peer condition, it might say, awesome, looks like we did that perfectly. Whereas in the tutor condition, it would say, awesome, looks like you did that perfectly. Here we have a video showing some of the utterances the robot said during the interaction and also how the setup of the study was.
Here, let's try to add a resistor to the circuit. Awesome, we made a good team. Here, try to add a resistor to the circuit. Awesome, you are a good student.
So, participants were brought into the experimental room and they interacted with the robot on a large table. In the middle of the table, they had a circuit board, and to their right and to their left, they had different circuit pieces and wires that they could add to the board. There was a tablet present on the table. However, this tablet did not present any type of help. Its only role was to say whatever the next task was. For example, build a circuit that has a constant light on. There was an overhead Connect camera that looked down on the table and saw which pieces the participants were adding and removing from the board and creating a personalized user skill model. A UR5E robot provided different help actions every 30 seconds, depending on which skills the users were lacking for the current task. Participants completed a total of 10 different circuit tasks with the robot, and each task took around 3 minutes long, and therefore the interaction with the robot was 30 minutes long. There were 37 participants in the study, 20 were in the tutor condition, and 17 were in the peer condition. To really test whether participants were learning more with one condition rather than the other, we created pre-test and post-test. And these were nearly identical to each other, but for one thing. We presented the post-test flipped either vertically or horizontally compared to the pre-test. This allowed us to test the exact same skills with the same difficulty without the participants realizing that they were doing the same test over again. Our first question that we asked was, did participants successfully learn new skills with a robot? And in both the peer condition and the tutor condition, the robot was able to successfully teach new skills to the participants. Next, we wanted to see whether there were any significant learning differences between the two conditions. However, at an initial glance, there were no significant differences between the two conditions. However, upon looking into a little more depth into the data, we realized that participants with low prior domain knowledge learn significantly more with the peer robot than the tutor robot. Now, this was really exciting news. By only changing this very small aspect about how the robot interacted with the participants, they were actually able to learn more. We also asked participants questions after the experiment ended about their perceptions of the different types of robots. And compared to the tutor robot, the peer robot was viewed as significantly more warm, smart and competent, friendly, respectful, and it's treating them more as an equal. In general, the peer robot was viewed more favorably than the tutor robot. We also looked into engagement, but we found no significant differences. There are several questions that arise from the study. The first being, why was the peer robot viewed more favorably than the tutor robot? The first reason why we believe this might have happened is that the peer robot was perceived as an in-group member, whereas the tutor robot was perceived as an out-group member. And psychology research shows that in-group members are viewed more favorably than out-group members. Another reason why the peer robots might have been viewed more favorably is that participants had lower expectations for it. Whenever we're introduced to another entity as them being a teacher, we create really high expectations. And when those expectations are not met, we might view them as less favorably. But the big question still remains, why were low prior knowledge participants learning more with a peer robot than with a tutor robot? And we leave this as a really exciting question that hopefully will be answered by future research. So to conclude, low prior knowledge participants learn significantly more with the peer robot than the tutor robot. And participants view the peer robot as significantly friendlier, smarter, and more respectful than the tutor robot. By seeing the peer robot viewed more favorably and participants learning more from it, more researchers in the future should really reconsider what types of roles robots are taking and really should start thinking about having robots presented more as peers or collaboratives, especially when interacting with adults. Thank you for joining my talk today. Please let me know if you have any questions and feel free to email me. Thank you. Bye.